Venn diagrams. Venn diagrams are pictorial representation of sets and their operations. Basically, we use closed curved figure and rectangle. The closed curved figure is used to represent individual sets, and rectangle is used to represent universal set, which contains many sets. Next, operations on sets using Venn diagrams. First operation, union of sets. The union of two sets A and B is defined as the set of elements which are either in set A or set B or in both A and B. This operation is denoted by union, that is nothing but U symbol. Let us see example. Example 1. Set A contains 3 elements A, B, C, and set B contains 3 elements K, L, M. Then A union B is equal to set of A, B, C, K, L, M. And note the point here, there are no common elements in both the sets A and B. Now let us represent A union B using Venn diagram. From the Venn diagram, the shaded area is called A union B. Let us see second example. Take two sets C and D. Then C union D is equal to 1, 2, 3, 4, 6, 8. Now let us see Venn diagram. First write common elements in intersection of both the circles 2, 4. Then the remaining elements from C are 1, 3. From set D 6 and 8. So the shaded region in both the sets is called union of C and D. Next, intersection of two sets. The intersection of two sets A and B is a set of elements which are in both the sets A and B in common. The intersection of the two sets is written as A intersection B. Note the point, two sets are called disjoint if they have no common element. For example, example 1. Set A contains 3 elements A, B, C, and set B contains 3 elements A, L, M. Then A intersection B is equal to 5. In both the sets A and B, there is no common element. Now let us see Venn diagram. Now write the elements which are in set A, B, C, set B elements K, L, M. The shaded area in the Venn diagram is called intersection of both the sets A and B. It is empty. So we can denote it using the symbol 5. Second example, take two sets C and D. Then C intersection D is equal to 2, 4. Because in both the sets there are two common elements 2, 4. Now let us see pictorial representation of C intersection D is nothing but Venn diagram. Now write the elements which are in common in both the sets in the shaded region, and remaining elements from set C are 1 and 3. In set D are 6 and 8. The shaded region in the Venn diagram which has two elements 2, 4 called intersection of set C and D. Next, difference of two sets. The difference of two sets A and B is a set of that contains exactly all elements in set A but not in set B, is denoted by A/B or A minus B. For example, set A contains 3 elements A, B, C, and set B contains 3 elements K, L, M. Then A minus B is equal to set of A, B, C. That is equal to set A. Here we have subtracted elements of set B from set A. No element of set B is present in set A. Let us see Venn diagram. The shaded region from A is A minus B. That is Venn diagram of A minus B. But A minus B is not equal to B minus A. Second example, take two sets C and D. Then C minus D is equal to set of 1, 3. Let us see Venn diagram. The shaded region in the Venn diagram is called C minus D. Next, complement of a set. The complement of a set A is a set of elements in the given universal set U that are not elements of A. The complement of a set A doesn't contain elements of set A, denoted by A complement or A dash. Sometimes we can represent A bar. So A complement is equal to universal set minus set A. For example 1, take an universal set U is equal to 6 elements and set A is equal to 4 elements. Then complement of set A is equal to universal set U minus set A, that is equal to set of elements C comma E. Let us see Venn diagram. A rectangle universal set U. Take a circle set A inside the universal set. All elements of set A subtracted from universal set U. Then remaining elements are C and E. The shaded region in the universal set is complement of set A. Second example, take two sets, universal set U and set A in set builder form. Universal set U is equal to set of x belongs to integers such that x square less than 20, and set A is equal to set of x belongs to integers such that x is greater than or equal to minus 3 less than 3. Now let us convert them into roster form. Universal set U is equal to minus 4 comma minus 3 comma minus 2 comma minus 1 comma 0 comma 1 comma 2 comma 3 comma 4. That is, the element x square should be less than 20. And set A is equal to minus 3 comma minus 2 comma minus 1 comma 0 comma 1 comma 2. By the condition x value should greater than or equal to minus 3 and less than 3. Then complement of set A is equal to universal set U minus set A, that is equal to minus 4 comma 3 comma 4. As I told you in example 1 Venn diagram, complement of set A is remaining elements in the universal set after subtracting elements of set A, that is the shaded region in the universal set. Next, symmetric difference of sets. Set of all elements which belongs to exactly one of the two original sets. This operation is written as A triangle B. It is nothing but A symmetric difference to B. In terms of unions and intersections, the symmetric difference of two sets A and B can be represented as A symmetric difference B is equal to A union B minus A intersection B. It can be written as the symmetric difference of set A and B is equal to A minus B union B minus A. Let us see examples. First example, take two sets A and B. Set A is equal to A comma B comma C. Set B is equal to K comma L comma M. Then the symmetric difference of set A and B is equal to A union B minus A intersection B, that is equal to A union B minus 5, because there are no common elements in set A and B, that is equal to A union B. So the set A union B contains 6 elements A comma B comma C comma K comma L comma M, that is equal to the symmetric difference of A and B. Let us see Venn diagram. The intersection point of set A and B is empty because there are no common elements in the set A and B. So in the Venn diagram, the shaded region is called the symmetric difference of set A and B. Second example, take two sets C and D. The symmetric difference of set C and D is equal to C union D minus C intersection D. The elements of C union D are 1, 2, 3, 4, 6, 8. Here we combined all elements of set C and D without repetition, minus C intersection D. Here we should write common elements in both the sets C and D. That is equal to set of elements 1, 3, 6, 8. That is the symmetric difference of set C and D. Now let us see Venn diagram and write elements of set C and D. From Venn diagram, the shaded region is called the symmetric difference of set C and D. Next, properties and laws of sets, which we can see in next video. Thank you.